Hello dear students, welcome to DAV Model Public School. Today we will see sign convention of spherical mirrors. So let's proceed. Earlier you have studied about mirrors, what are mirrors, what are different types of mirrors, plane mirrors and spherical mirrors. Again, certain laws of plane mirrors, certain laws of reflections and all. Now we will study about sign conventions for reflection of spherical mirror. You will understand this rule afterwards. First, you can go through this afterwards. First, we will study about sign convention with this animation. Then you can proceed with the first slide and analyze whatever I'm about to tell. Now, this is a spherical mirror. This is a spherical mirror. Yes. Now, if a spherical mirror, it is coated with, hold on for a second, yes. If this is a spherical mirror and if one side is coated with nickel or lead oxide and a combination of lead oxide, it becomes an opaque medium. From one side, it is an opaque medium and from one side, it is a reflecting medium. So this is a concave mirror. We will understand the sign convention of reflection of spherical mirror through this concave mirror. It is even applicable in convex mirror. Both things are identical to it. So sign convention, it is the backbone of the light chapter. Many numericals and all are related with this concept. Here in this chapter, hardly few formulas are there, but the major concept is related to sign conventions. If you are familiar or if you understand the concept of sign convention, it would be easy for you to solve numericals. So let's see this sign conventions properly. This is a spherical mirror. More precisely, it is a concave spherical mirror. Now, let us see. This is a concave spherical mirror. The exact center of this concave mirror, spherical mirror, is termed as pole. This point is termed as pole. An imaginary line which is passing through pole, it is termed as principal axis. I am naming this principal axis as x and x dash. So this point is termed as pole, that's why it is written, that's why I wrote pole. And this is principal axis, the yellow line which is indicated over here. I am naming this as x and x dash. To understand the concept of sign conventions, I am considering an object. I am naming this object as A and B. The upper portion is termed as A and the lower one is B. It is indicated by an arrow. Now, the first sign convention says that object is always on left side of the spherical mirror. This is a mirror. Object would always be on left side, not on right side. This is the first sign conventions. Though in practical purposes, this statement will violate the rule. But for understanding reflection, you have to consider that object is always on left side. And all questions and all will be based in considering the fact that object is always on left side. Don't get confused that object will be on right side. Always and always object would be on left hand side. The first rule says that object is always on left side. And the ray of light will always go from left to right. Left to right. This is also the second rule. It will always go from left to right. Since suppose I am considering this object as a candle, the ray of light, it will always go from left to right. Arrow, small arrow over here. Therefore, direction of incident light is from left to right. Always and always. It is always from left to right. If this is the object, direction of a ray of light is always from left to right. And this blue portion is the measuring distance of the object. This blue portion. So all distance are measured from pole. This is the pole, so all distance should be measured from pole. Here this is pole, so I'm placing my ruler in such a manner that first I will start counting from the pole towards the object. Since I have to measure this distance, so how can I measure? First I will start with pole and I will end with the object, where is the object is residing. So all distance should be measured from pole. This is the second and important rule. All distance are measured from pole. Distance towards left is taken as negative. Distance towards left. This is left. Whatever things I am measuring, distance towards left is taken as negative. No matter if you are measuring object distance, focal length or image distance, whatever things or which is opposite to the incident ray of light, it will be negative. This is the direct measuring distance and this is the direction of incident ray of light. Since this direction and this direction are opposite, so the measuring distance, whatever things you are measuring, it will be always and always negative. Now, if you are measuring distance in the direction of light, now this blue portion is the measuring distance and the direction of incident ray of light is going in this direction. Since the direction of ray of light is going in this direction, and as per the second sign convention rule, all distance should be measured from pole. So this is the pole portion, so this should be measured from pole. Now since as you observe properly, direction of incident ray of light and direction of measuring distance are in same direction. This ray of light is also going in this direction and measuring distance is also from pole towards the certain thing. Since both are in same direction, so whatever things you are measuring would be always and always positive. So it is written over here, distance toward right is taken as positive, whereas distance towards the left of the mirror is taken as negative. Always remember, when the ray of light is going in this direction, measuring distance is opposite, it is negative. When ray of light and the measuring distance are in same direction, it is positive. Now, the other sign convention rule says that anything above the principal axis is taken as positive, anything above the principal axis positive, anything below the principal axis it is taken as negative. By mistake I wrote positive over here. Height below the principal axis it is taken as negative. It should be negative over here. It is negative over here, not positive. Kindly correct it. Now, as I was telling earlier, this yellow light is incident ray of light and measuring is this one. Since both are in opposite direction, whatever things I am measuring, it is negative. Hence it is negative. Now, if ray of light is going in this and measuring distance, it is indicated by blue portion, it would be whatever things you are measuring, it would be positive. Now, what distance to measure object distance, you use the symbol U. Object distance is measured as U and image distance is measured as V. Now, if you analyze this properly, if there's a situation to measure the object distance, your answer would be negative. Why is it so? Because ray of light is going in this direction and as per the second sign convention rule, all distance should be measured from pole. Since both are in opposite direction, object distances would be negative over here. Now what if I was supposed to find out image distance? Now as you can see, ray of light is going in this direction and measuring distance is going in this direction. Again opposite things are happening again, so my image distance would also be negative. Again, if suppose this is a possibility, if the virtual image is forming, then my V would be positive over here. Why is it so? Because the measuring distance and the incident ray of light are in same directions. Hence, my image would be positive over here. I hope you have understood sign conventions properly. Now, how to use mirror formula? We have a specific formula, that is 1 by f equals to 1 by v plus 1 by u. This is known as mirror formula, where U is object distance, V is image distance. Again, it is written object, it should be image distance, and F is focal length distance. Again, correct this statement. V is image distance, not object distance. So this 1 by F equals to 1 by V plus 1 by U. This derivations and all, it is not there in your syllabus. It is there in 11th standard and 12th standard. And as per the reduction of syllabus, mirror formula, derivation of new mirror formula is excluded from it. So you don't have to worry how this equation came. You have to simply remember mirror formula is given by 1 by F equals to 1 by V plus 1 by U. Where F is the focal length, V is the image distance, not object distance, U is object distance. Now, another formula which is associated with the sign conventions and all are linear magnification. Linear, which is going in one single direction. So linear magnification is defined as the ratio of height of the image to the height of the object. Here, the height of the image, it is taken as h dash, and height of the object, it is taken as h. Or you can simply write height of the image as hi, or height of the object as ho, as per your wish. So what is magnification? Whenever you take a ratio of height of image upon height of object, you will get magnification, that is m. Magnification is denoted by small m, or you can even denote it by capital M. So magnification m is height of image upon height of object. Another formula for linear magnification is this. Linear magnification is the ratio of height of image to the height of the object, hi upon ho. Second formula is m equals to minus v by u, where v is image distance and u is object distance. Again, how this came, you don't have to worry, it is not there in your syllabus. So simply you have to remember, for magnification you have two formula, m equals to hi upon ho, m equals to v upon minus v upon u. Now again, certain difficulties arises in terms of students when to use this m equals to hi upon ho and m equals to minus v upon u. It completely depends upon situation, what sort of numerical is there. Accordingly, you have to use this formula. If suppose height is given, height of the image is given, and height of the object you are supposed to find out, then you can use this formula. Again, if image distance is given, so depending upon situations, whatever given conditions are there, you will use and alter this formula accordingly. Now certain things which is related to magnification, which might be asked in MCQs and all. Now, if mod of m equals to 1, as you can see over here, two lines are there. Inside two lines, m is written over here, which it indicates mod. It is a symbol of modulus. So mod of m equals to 1. Image is of small size. So which means the magnitude of magnification is 1. When whatever things which is written in mod, which means we are talking simply about number. No, we are not talking about sign. Whatever things it is written in modulus form, we are talking about number. Remember this statement, we are talking about number, not sign. So whenever magnification comes out to be exactly 1, which means image is of same size as that of object. Image is of same size as that of object. When magnitude of magnification is greater than 1, image is enlarged. In the same way, when magnification, whenever you take the ratio, if the value comes in between this range, from that, in this particular range, whatever it is given over here, you can simply analyze that the object and image is of different situations. When it is 1, it is of same size. When it is greater than 1, it is enlarged. When less than 1, it is smaller in size. When it is greater than 0, it is erect. Less than 0, it is inverted. Now, another important point to remember about magnification is that the magnification in case of convex mirror is always positive, because image form is always virtual and erect. In convex mirror, image formed is always and always virtual and erect. Whereas in concave mirror produces negative magnifications. In concave mirror, you will have positive and negative both. In concave mirror, negative magnification when image is formed by its real. When image is real, when image is real, magnification is negative. When image is virtual, image is positive. Magnification is positive. Analyze this statement properly. A convex mirror produces both negative as well as positive magnification. When it will produce negative magnification would be produced when the image is real, and positive magnification would be produced when the image is virtual. I hope you understand the difference between real and virtual. Real means it can be obtained on screen, and virtual means it cannot be obtained and cannot be felt on screen. I hope you have understood the concept of this sign conventions. Thank you and have a nice day.